Alright, in this lesson I'm going to make a connection between right triangle and unit circle. Why you do that? Because that will allow you to understand it better, visualize it better. You will be able to solve physics problem. You need visualization, understanding both. This give you visualization, understanding both. Alright, so let's start our conversation with unit circle. When we talk about unit circle, well, let's show you the right triangle. When we talk about right triangle, we actually talk about which is defined by Pythagorean theorem. So which is defined with Pythagorean theorem, a square plus b square equal to c square. And when we talk about unit circle, we are talking about x square plus y square equal to 1. So as you see that this is a special case of Pythagorean theorem. Okay. All right. So the unit circle, what makes it unit circle is the radius 1. So this is the radius. This makes it the unit circle. Now let's write to the unit circle all the angles of the unit circle, not only first quadrant but all the quadrant. So this would be plus plus, this would be minus plus, this would be minus minus, this would be plus minus. All right. So this one is 1 comma 0 because the cosine 0 degree is 1 and sine 0 degree is 0. So this is cosine 90 degree is 0 and sine 90 degree is 1. Cosine 180 degree is 0 and sine 180 degree, cosine 180 degree is minus 1 and sine 180 degree is 0. Cosine 270 degree is 0 and sine 270 degree is minus 1. Okay, so these are the special case. They don't hold a triangular inequality. So they are not, we cannot use them to represent the both leg of the right triangle. All right, they are the special case. Now I'm gonna show you the legs that defined by Pythagorean theorem. Okay, so all right, so this is my 30 degree, this is my 60 degree, and this is my 30 degree, this is my 45 degree, and this is my 60 degree. So 30, 45, and 60. I'm going to use the different color to write 30, 45, and 60, and in a few seconds you're gonna see the reason why I'm doing that. All right, in a few seconds you're gonna see why I'm doing that. Okay, so here's how I want you to remember them. So you're gonna write 2 comma 2. You put the 2 down the stairs. You write 1, 2, 3, and then 3, 2, 1. You square root everything. If you do square root of everything, you see that square root of 1 is just 1. Square root of 1 is just 1. So you can erase them. And everything else is the same. So what does they represent? They represent the both leg of the right triangle. They represent the both leg of the right triangle. This is the horizontal and this is the vertical. This is the adjacent and this is the opposite with respect to the angle. If you get the both leg, you would be able to get the other side. Okay, now this will allow you to find all the angles on the fourth quadrant. So let's see what I mean. All right, so if this one is the square root of 3 over 2, so I'm going to write a square root of 3 over 2 comma 1 over 2. So this one is positive but this one is negative, so I'm going to carefully put negative over here as I show you that the y component is negative. All right, now let's do this one. All right, so what is this one? A square root of 2 over 2 comma square root of 2 over 2, but this one is negative. So this one is as you know that this one is 30 degree, so this one is 330. This one is 45, and this one is 315. This one is 1/2, comma square root of 3/2. Of course negative. This one is 60 degree, so this one must be 300. Alright, so you have half of the unit circle finished. Now we're going to do the remaining half of the unit circle. This is pretty cool, you see. Alright, so this, if this increases by 30 degrees, so this one has to increase by 30 degrees. If this one 90, this one must be 120. This one increased by 15, so this one increased by 15, so 135. From here to here increases by 15. So I'm going to increase by 15 again. I wanted to use the different color, so for the same reason. So 135, let's make it red. And this is 150. And then let's make it blue. The 120. So 120. Alright, so every point, to value make a point, to value make a point. What is the point over here is the length over here. Okay, what we call point over here, we call length over here in a right triangle. Alright, so now as you see, I will carefully do the same thing. I'm going to write both values. I'm going to write both value. Two value makes a point in 2D two-dimensional wall. So I'm going to carefully write 2, 2, 2, 2, 2, 2, just I did over there, and I'm going to write 1, 2, 3, and 3, 2, 1, and I'm going to carefully write negative, negative, negative to satisfy this one. All right. So that's it. But don't forget to square everything. All right. So this is your third quadrant. This is your third quadrant. Now we're going to get to the, this is your second quadrant. Now we're going to get to the third quadrant. So let's take out the blue and do the blue over here. Oh, let's take out the red. Start with the red. I just drop the top. All right, start with the red. Alright, so this one is 150, this one is 180, and this one must be 210. So then this is the square root of 3 over 2, comma 1 over 2. This is just 1 over 2. You can erase the, because the square root of 1 is equal to 1. So don't forget this is both negative, both legs are negative. As you see, both values are negative, both legs are negative. Alright. So now what are you going to do? You're going to take out the black. You're going to take out the black, and this is going to be 225 degree. So what is 225 degree? 225 degree is both component of the same. The magnitude of the both legs are the same. Square root of 2 over 2 and square root of 2 over 2. Don't forget to put the negative. That makes it third quadrant. Now I'm going to take out the blue, and I'm going to draw the final point. The final point would be 1 over 2, comma square root of 3 over 2. Alright, don't forget to put negative. Okay, so now this is a full unit circle. Full unit circle, I didn't do, I didn't have to think a lot. I mean, it's pretty easy. You can do the same. Now we're going to make the connection, and we're going to prove that. But before we prove that, I'm going to prove the Pythagorean theorem very quickly, because this is connected with Pythagorean theorem. So I'm going to give you two proof of Pythagorean theorem. Number one is visual proof, Okay, visual proof. So let's see 3, 4, 5. 3, 4, 5, a Pythagorean triple. So a square plus b square equal to c square. That means 3 square plus 4 square is equal to 5 square. That means 9 plus 16 is equal to 25. Let's see whether I can show it visually. Alright, so if this is the Jason and this is the 3, so I have 1, 2. Let's make it a little bigger. Alright, so I have Alright, so I have 1, 2, 3. Alright, I'm going to do it a different color because it doesn't make sense to do it in the same color. So 1, 2, 3. So I have 3 over here, but 3 square is 9. So let's make 9. So now I have 9 over there. If you don't believe there are 9, you can count them. Trust me, there are 9. This is 4. This side is 4. This side was 3. This side is 3. So 3 square is 9. So this side is 3. This side is 4. Alright, now 4 square is 16. So I have 1. So 1, 2, 3, 4. So it's 16 over here because the 4 square is 16. So I have 9 over here. I have 9 over here. I have 16 over here. So 16 plus 9 is 25, which is amazing. You're going to see that. So this is 5. 1, 2, 3, 1, 2, 3, 4, and 5. So 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 4, 5. So there are 25. All right, so this is 25. So this is a visual proof. Okay, this is a visual proof. Now I'm going to show you the algebraic proof, which is more important. Okay, so algebraic proof, I'm going to quickly show you algebraic proof of Pythagorean theorem, and that is all right. So A B C A B A B A B A B, and this is a square. So this is C C C and C. Now I have 2 square. I have a square outside, which is red. I have a square inside, which is blue. All right, so I'm going to write the area of red equal to write area of blue. Let's write area of blue. Area of blue is equal to area of red. This is not true, by the way. Area of red is not equal to area of blue, because as you see, the blue is the smaller and red is the bigger. So I have to subtract something. So I have to subtract this one, then area of blue would be area of red. So I have to subtract this one. What is this one? This one is a triangle. So half AB. How many? 1, 2, 3, 4. 2. So area blue. What is area blue? Base times height. What is area of red? Still base times height. And then minus 2ab. Minus 2ab. Alright, so now B. So what is base? Base is C. What is height? C. What is base? Base is AB. A plus B. What is height? A plus B. Minus 2ab. Alright, so C times C is C square. This is A square plus 2ab plus B square minus 2ab. 2ab cancel. So C square is equal to A square plus B square. Alright, so proof. Now, so that we prove that, we now know that this is defined by Pythagorean theorem. This triangle is defined by Pythagorean theorem. So I'm going to write, this is 30, 60, 90, 45, 45, 90, and 60, 30, 90. All right. So what we are looking at? We are trying to say that is to represent the length. Okay, the two leg. This point represent the two leg over here. This point represent the two leg over here, and this point represent the two leg over here. And by showing that, we're going to make connection between right triangle and unit circle, which I think nobody never did before. You can look at the internet, and I don't believe anybody ever did it before. Alright, so this is opposite to 30 degree, which is x, opposite to 60 degree, which is x root 3, and opposite to 90 degree, which is 2x. Alright, now SOHCAHTOA tell us sine theta is equal to what? Is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse. So what is opposite? Opposite is x, and hypotenuse is 2x. Okay, and let x be 1. Let x be 1. Let x be 1 for all cases. So then I have sine 1 over 2. And the cosine, let's see, cosine. Adjacent, which is square root of 3, because x is 1 and hypotenuse is 2. Alright, so I have sine and cosine. So 30, 60, 90 degree triangle give us cosine comma sine. So cosine 30 degree comma sine 30 degree is square root of 3 over 2 comma 1 over 2. And that's exactly what we got here. Check. So the point in unit circle is equal to leg in a right triangle. Let's put the 45, 45, 90. This is x, this is x, this is x root 2. Alright, this one was given by Hipposus. Alright, so, and we're gonna say let x be 1. Alright, so what is the sine theta? Sine 45 degree. Sine 45 degree is opposite over hypotenuse. What is opposite? 1. What is hypotenuse? Square root of 2. Cosine 45 degree. Adjacent over hypotenuse. Adjacent is 1 and hypotenuse is square root of 2. Alright, but this and this are not the same. Okay, so now let's see. How different are they? We can quickly multiply this one, both of them by 2. So you're going to multiply this one by 2 and multiply this one by 2. So we get 2 square root of 2, and that's still not going to be the same. So what we're going to do, we're going to multiply, we're going to rationalize them. We're going to both rationalize them. So cosine 45 degree comma sine 45 degree. All right, let's first rationalize them. How are we going to rationalize it? Top and bottom by square root of 2. So what do we get? The square root of 2 over 2. And top and bottom by square root of 2. So what do we get? The square root of 2 over 2. Alright, so cosine 45 degree, after we rationalize, is square root of 2 over 2. And sine 45 degree is square root of 2 over 2. So we proved that the point and the unit circle are the legs on the right triangle. Pretty awesome, huh? Alright, now we're gonna, what left is the 30, 60, 90. So opposite to the 60 is, what is opposite to the 60? Alright, forgot, but I remember what is opposite to the 30 is x root 3, I believe, and 2x. If you forget, you can use the Pythagorean theorem to check that. But I see that 4x squared is equal to 4x squared. What do you mean? ax squared plus b squared equal to c squared. So 4x squared is equal to 4x squared. Okay, so they work. Good. Now we are letting x is equal to 1. Now in this case we have this. We are proving this. We are proving that the point at 60 degree are the legs of the right triangle. The 60 degree right triangle. All right, so what do I mean? Let's start with sine 60 degree. Sine 60 degree is opposite of our hypotenuse. Opposite is root 3 and hypotenuse is 2. Cosine 60 degree. Cosine 60 degree is adjacent over hypotenuse. Adjacent is 1. Hypotenuse is 2. All right. So this I don't have to rationalize it. It's already good. So cosine 60 degree comma sine 60 degree is equal to half comma square root of 3 over 2. And that's exactly what you see over here. So the point on the unit circle, how many points possible on the unit circle? Infinite. But how many points are important? 3 on the first quadrant, 3 on the second quadrant. So 6. 3 on the third quadrant, 9, and 3 on the fourth quadrant, 12. These 12 points are defined by Pythagorean theorem. Another 4 points are important. I put them separately because they are not defined by Pythagorean theorem because triangular inequality doesn't hold. Okay.